Greetings to all. Myself, Dr. B. Pratap Reddy. I am working as a DST Inspire Faculty Fellow at the Department of Electronic Systems Engineering. And TA for this course is Shyam Sundar Nair. He is a PhD student and he will assist to do the rewinding of electric motor in this lab session. So we will consider a motor with 36 slots and 6 pole, and it has to rotate at a speed of 1000 rpm synchronous speed, and with respect to the slip, the speed will vary from 950 rpm to 1000 rpm. And I will show the motor, and then we will dismantle the motor completely, and we will identify all parts of the machine, and then we will remove the completely whatever the winding existed inside the machine. Then we will start making the coils as per the given voltage rating and given power rating. Then after making the coils as per the voltage rating, how many number of turns require and what is the gauge as per the theoretical lectures, we will calculate and we will do the rewinding. And after that, one by one we will insert into the machine and we will again assemble the machine completely, then we will test it. And now I will show the motor. This is the motor, 3-phase induction motor, and we are going to rewind this motor for a power rating of 200 watt and 100 volts. And here we can see the terminal box, 3-phase star connected terminal box. Star connection will be done inside and 3 wires are coming outside, R, Y, B. And from the scratch, how to rewind the motor, we will see step by step. So first step, we have to dismantle the motor. Then we have to remove the winding completely. So as per our power rating and voltage rating, we have to make the coils, and one by one we will insert the coils again, and then we will do the stubbing and other things. Then we will do the threading and varnishing and other things, and again we will assemble the motor. And then we will test the motor with no load V/F control. Yeah. Now we will dismantle the motor. So this is shaft side and this is non-shaft side, non-shaft end side. So this side generally fan we used to fit for thermal management. Here for this motor, fan is already removed. So as per the motor, we have to dismantle front side as well as back side, like drive end as well as non-drive end. After removing the screws, we have to remove the enclosures with by hammering, and we have to remove the terminal box also. But before doing these things, we have to wear the gloves as a protection issues. For removing the screws, it may be required or may not be required, no problem. But from this step onwards, we have to wear the gloves for safety issues. Now I will remove the enclosures on both sides by doing little bit hammering on both sides. Now we can see here, this is the rotor, this is the squirrel cage rotor, and this is the enclosure on non-drive end side, and drive end side enclosure will be this thing, that also we will remove. So this is the drive end side enclosure, and bearings also we can observe here. These are the bearings, drive end side, and non-drive end side also bearings will be there. This is squirrel cage rotor, and after removing the rotor, we have to remove the terminal connections also. These are the terminals terminal connections going to the supply, so that also we will remove. Just make sure that this motor is decoupled from the supply. And after turning off everything, then we have to remove one by one. So 3 connections I have removed, the terminals which are going to the supply. And these are the 3 wires which are coming from the 3-phase windings after making the star connection. That also we have to remove. So these are the 3 wires which are coming from inside of the motor. Now we will see how many number of slots are there. We have to identify first. So we have to count from 1, 2, 3 like that up to. So I am counting the number of slots to design the winding. Let us say after counting the number of slots, I got 36 slots are there as per the problem statements. 3 phase 6 pole is the problem statement for 100 volts and 200 watt. So with respect to the 3 phase 6 pole and 36 slots, we can design the double layer winding. Slots per pole per phase will come 36 divided by 6 pole into 3 phases. So 2 slots per pole per phase will come. So after this thing, we will remove the threading. And in industrial motors and practical motors, varnish also will be there. So if varnishing is there, we have to use the thinner to remove the varnish, such that it will one winding to other winding, the smoothness will come, like the hard attachment will come with respect to the varnish. That will be removed with respect to the thinner. First, as a part of rewinding, we will remove the threading. Like this we can remove the complete threading, and same way on the other side also we can remove the threading. So this is white color one is the threading, and we have to remove the complete threading in order to remove the coils. So after removing the threading on both sides, we have to, if varnish is done, we have to cut the winding at one particular side, and then we have to remove the winding. So we have to remove the sticks first, then we have to remove the enclosures and everything. In practice, varnish also applied. In that case, first we have to apply the thinner, then we can use some cutters to remove the windings. Here there is no thinner, that's why I am doing directly. Like this we have to remove all sticks first. What we have to utilize it for slot closing. Then we can remove this insulating paper, this white color one. Then it is easy to remove the conductors from the slot. After removing the sticks and the slot enclosures, this insulating paper, then one by one we can remove the coils from the slot. Here there is no varnish, that's why we can do from slot itself directly, like this fashion. So whatever the way we have inserted, same way we can remove the windings. So this is first winding I have removed. So the next we have to remove with respect to that particular winding. So here top side conductor first we have to remove. After that we can remove this coil easily out from the slot. So like this we have to remove all coils. So first coil I have removed. This is the same way. You can remove this coil also. So remove like this one by one all coils out from the machine. Otherwise we can use the cutters to remove the winding directly. So this is another coil. So like this, all coils we have to remove from the slots. Generally, we will apply the varnish. That this much easily windings will not come outside. So we have to use the thinner. Otherwise, directly with some cutters we can cut the winding at one side. Then from other side we have to remove the windings. So here there is no thinner. That's why I am doing directly in this manner. Now I have removed all windings from the machine, so we have to remove these papers also. These are the insulating slot liners we used to call, that will insulate the conductors and the mission frame, or conductors and slot. So this is the empty 36 slot core. So from this point we will start designing the rewinding of motor. Okay, as per the given power rating and voltage rating, we will design the winding. So after removing everything, like all windings we have removed, this is the empty core, 36 slots are there. So we have to design the winding for 6 pole and 3 phase double layer winding. So first we have to calculate the number of turns as per the voltage rating. Voltage rating is given per phase, RMS is 100 volts and 200 watt rating, and current rating we have to calculate accordingly. It will come 1 ampere, 0.8 to 1 ampere it will come. So as per the pole, number of poles, we have to calculate the pi d by p. Based on that we have to calculate the arc length of the coil, and then based upon the current rating 1 ampere to 1.5 ampere for safety side we can consider, and then SWG related to that is 23 or 22 SWG we can select. Based on that SWG we will make the coils that we will see now. So this is the winding making machine. With this we can make the number of coils as per the machine. So based upon the arc length like pi d by p, we have to calculate one complete turn length. Based on that thing we have to fix, depends upon the step. This step has different circumference, this step has different circumference, this step also different circumference. So based upon the machine we have to fix the mean length. Then let us say I am considering this second step. So with respect to the second step, here number of turns will be visible. So let us say per coil 50 turns are coming. So based upon the 50 number of turns per coil, we have to make 50 turns in each and every coil. So like this we can make the coil. So 50 turns we have to make. So this is after making the coil as per the number of turns. We have to tie on both ends for easy insertion of windings. coil 1 as per our design. Like this 36 coils we have to do for double layer winding with respect to 36 slots. So like this 36 coils we have done now. So these 36 coils we have to insert in the machine one by one. After making the all coils, we have to insert the slot liners. Like this insulating paper we can take, and we have to measure the length of the core. Based upon the length of core, we have to cut the this insulating paper. Then one by one we have to insert inside the slot. See, after placing all slot liners, the core will be like this fashion. Then whatever the coils we have done, like this 36 coils, we have to insert one by one, and the slot opening will be 2 to 3 times the conductor cross sectional area. In some machines 2 to 5 times it will be there. So I am inserting the conductors in the slot one by one. So this is one coil side and this is second coil side. So first coil side we have to insert in the slot 1 bottom side, and next coil side we will insert in some other slot. We have to do slowly one by one, otherwise there is a chance of enamel removal. So after placing the coil, we have to place the slot separator. So this is the coil separator. Then we will take one more coil. So this is 1 dash conductor which is placed at the bottom side. The second end we will place at the end, but the top side we will place the conductor now. So this is the coil side, which are what we are placing in slot number 1 top side. We can use stick to insert the conductors into the slot. So after placing both coils, we have to place the another slot liner at the top side, that is this one. So first slot is filled with both coil sides. We can see 2 coil sides are placed in slot 1. Then we have to place the stick for closing the slot. So we can see here this slot is filled. Next, the second side of this coil we have to place in slot number 7 bottom side. So this is first, second, third, fourth, 5, 6, 7. In 7th slot we have to place the conductor. So second coil side I am placing here. So second coil side is placed. Then we have to place the slot liner or coil side separator. This one. So slot 7 bottom side conductor we have placed. So we have to go in sequence. Now slot 7 top side we will fill because it is a double layer winding. So whatever the slot we have filled, so from that slot we will start again. So slot number 7 top side I am placing the coil side again. So we can use the stick like this fashion to push the conductors inside the slot. After placing the coil side, we have to place the slot closer like this fashion, which will insulate the slot and conductor. So we can see here the slot closer is placed. After that we have to insert the stick slot closer, that is this one. So depends upon the motor size and slot size, we can select the stick and we have to insert to close the slot such that conductors will not come outside the slot. So we have to use the rubber hammer such that enamel will not go bad. So after placing the slot number 7 top side, the coil side, then from 7 to 6 right coil pitch, 7 to 13th slot it will go, 13th slot bottom side. So from here 13th slot bottom side means this one we have to place. So this is the 13th slot. We have to do the winding carefully. The enamel should not go bad. We can see here now, after placing all coils, whatever the coil we have inserted first, that we will place now at the top side of the last coil, at the top side of the slot where we have placed the last coil. We can see now all 6 coils we have placed with respect to phase A. Then adjacent to this coils we have to place another 6 coils such that A phase winding will be completely done. Before placing those coils, we have to mark these ending terminals of each and every coil. So now 6 coils we have placed, right? So total 12 terminals are there. So these 12 terminals we have to mark it with stickers. So based upon number of, like whatever that may be the slot where we are placing, so we have to mark it, like 1 is top side and 1 dash is at bottom side, like that. So these are the 12 terminals. Now everything is marked. So let us, for example, slot 1, 2 coil sides are there. So bottom side coil is marked as 1 dash and top side coil is marked as 1. So same way we have to place all 36 coils. After placing all coils, and each and every coil we have marked as 1, 1 dash, 2, 2 dash, like that. For example, in slot 1 we have placed 2 coil sides as per the double layer winding. Top side coil is represented with 1 and bottom side coil side we are representing with 1 dash. Like that it is marked in for each and every slot. So now we will do the stubbing. Then we will connect the winding connections. At the end we will bring the 3 terminals outside, and other side 3 terminals will make the star connection. Now we will start with the stubbing, and already we have placed the slot closers, that is insulating paper, this white color one, and sticks also to close the slot such that windings will not come outside. and for stiffness of the winding we can make the varnish at the end and threading also at the end. So now we will do the stubbing. So as per the winding diagram, we have to stub the 2 coils, that is slots per pole per phase. That 2 coils are, first coil is 1 to 7 dash, second coil is 2 to 8 dash. To make one stubbed coil of these 2 windings, we will connect 1 and 7 dash and 2 we will connect, because 1 is starting terminal and 8 dash is ending terminal of stubbed winding. So we will connect 7 dash and 2. So this is the 2 and this is 7 dash. Okay, these 2 wires we will connect to make the first stubbed winding. First we will remove the enamel with sandpaper. So we have to remove the enamel completely, and then the second end will be this thing. This is 7 dash. Now we will take the sleeve like this, insulating sleeve. So we will insert before making the joint, and then we will connect these 2 wires. This is nothing but stubbing. So I am connecting 7 dash and 2, and for better conductivity, so this winding joint we will do the soldering also. Now we will do the soldering. We can pause and yeah, now soldering is done. After doing the soldering, and we can check the continuity with multimeter, then this insulating sleeve will push it to here to cover the winding connection, such that it will not come in contact with any other winding. So like this we can place the insulating sleeve. In general we have to utilize the heat sleeve also before placing this insulating sleeve. Here directly I am utilizing the insulating sleeve. This is first stubbed coil. So this is starting and this is ending with respect to the first stubbed coil as per our winding diagram. Next stubbed winding will come. We have to connect 13 dash and 8. So here 7 is there, that is starting, and 13 dash is there here for the next under next pole, that is first coil, and then 8 and 14 is the second coil. So these 2 coils we have to connect as one coil, and we will make one stubbed winding. So we will consider 13 dash and 8. So this is 13 dash, and then this is 8, we have to see, yeah, this is 8. So these two wires we will connect to make the stubbing. Yeah, these two you can make. Yeah, first take the sleeve. Yeah, here also we'll take the sleeve before making the connection, and then we will insert. Then we will make the joint. So this is the joint. Now we will do the soldering for better conductivity. So after doing the soldering, again we will do the same procedure. Like we will bring the this sleeve to cover that winding connection, such that it will not come in contact with any other winding. Same way we have to do the stubbing with respect to all coils. As per the winding diagram, we have done the all stubbings, like 18 stubbed windings are there. That 18 stubbed winding connections we have done intermediate connections, and then 3 terminals at one side and 3 terminals other side we have brought it out. These are the 3 terminals to do the star, and these are the 3 terminals to make the 3-phase supply terminal connections. Now we will do the star connection as well as power supply terminal connections. So first I will make the star connection. We can see here these are the 3 terminals to make the star. We have to remove the enamel, then we have to take the bigger sleeve like this, and then we can cut it. So first insert that bigger sleeve into the winding, then make the connections and then soldering, same way how we have done the soldering for stubbing. So this is the star connection. Now I am doing the soldering for better conductivity. After doing the star connection, then we will cover that connection with the same sleeve. So this is the star connection, and these 3 connections we will extend this wire length and then we will bring it out from the terminal box. So in order to extend this length, we have to consider the copper wires like this manner, same copper wire. Otherwise normal 5 mm cables also we can consider, and then we can bring it out. Then after soldering, we will insert the sleeves like this fashion. So we have to mark the terminals, which one is R, which one is B, which one is Y, like that, or ABC. So this is A. I am marking as per my convention, and then this is B. So this will be the C. Now we have to bring these three terminals outside from to the terminal box. Here there will be a hole near the terminal box. From there we have to bring it out. I will show you that. Here we can see the hole. From here we have to bring it out. You can see this is first A face, then this is B face, and then this is C face. So at the end we will give the connections to this terminal box, and then external connections to the supply also we will give from this point. So this winding is done. Now we will assemble this motor by doing the threading and varnishing. Before doing the threading and varnishing, we have to test each and every phase continuity, and there should not be any short with phase to body. That we can see now. If any short is there, my multimeter will give some sound like that. Just we are seeing from body to body. Now from each and every phase to body there is no short. That test we have to do. After that only we have to do the threading and varnishing. So like this thread also we can utilize, or like this thread of cotton thread also we can utilize to do the threading. In order to make the needle, take the copper wire and you can fold it in this fashion and then bend it in this manner, and you can make it like some needle kind of thing to do the threading. Then we can cut in this fashion. So this is the needle to do the threading. Now threading is done. On both sides we have to do in the same way the threading. After doing the threading, we have to do the proper hammering with rubber hammer. So rubber hammer we have to take, and we have to do proper hammering like this manner, such that rotor we can install or we can insert freely, and there should not be any obstacle to rotate the rotor. We can see here both sides the threading is done, and we have to do the hammering in this fashion. And it should not touch to the frame also, if otherwise the enamel with respect to the windings will go bad. Both sides we have to do the hammering properly. And then we have to insert the rotor, then we will do the assembling now.
So we have completed the winding of the motor. So after the completion of winding, we have found that the motor is rated for 100 volt and 200 watt. This is the auto transformer which we are going to supply to this motor. This auto transformer is rated for 415 volt and 28 ampere. We have measurement instruments like current probe, multimeter, voltage measurement probe and tachometer to measure the speed of the machine. So we can start testing the motor under no load operation.
Now we will give the supply voltage as per the rating of the motor. The winding is done for 100 volts. So as per that thing, I am giving 100 volts phase RMS. So we can see the motor is starting slowly, and here we can see the motor shaft is rotating, and in the oscilloscope voltage waveform and current waveforms are shown. The current is lagging behind the voltage as per the inductive type of load, and here this is the current probe which is measuring the current. And now we will see the speed of the motor with tachometer, that is this one. Now we will measure the speed of the motor with tachometer, and we can see the speed in tachometer display, and speed we can observe that it is varying from 950 to 1000 rpm. Yeah, so now we can see that 978 rpm and 980, like that it is varying.